Next up, we have Shabana. So Shabana is a PhD candidate from the so she's a PhD candidate in climate change and financial stability from the Victoria University of Wellington. Before she steps into academia, she actually worked in the banking sector for more than 12 years. So I will pass on to Shabana. And thank you.
Okay, so you're gonna have to tell her. Go forward a slide. Sorry about that. We lost control.
Okay, so we can.
Oh,
Yeah, that would be better. Okay, you can put here so that I can really, yeah, use this one. Okay. So the basic idea behind this research is based on this idea where we just use droughts as an environmental factor or climate factor. And then we try to link this climate factor with the financial sector through agriculture, because the drought is the phenomena that can really enter into the financial sector through the agriculture. The agriculture sector is being hit by the droughts through their production can be reduced during drought seasons, and ultimately they can have a low income, and because of the reduction in the income, they may be having a financial crunches, and they will go for the increasing debt from the market. So as there will be an increased farm debt, there may be a chances that if they are having a reduced income due to the drought or environmental seasons, they may not be able to pay off their loans on time. So there can be a chances of increased level of non-performing loans in the banking industry. So this is how we thought, like how this climate risk can really enter into the financial sector or directly to the banking industry through the agriculture sector. So when we just look into the non-performing loans in the literature, we have seen, like most of the studies, they have tried to find out the factors that can really incorporate into the non-performing loans. So first, there are a lot of studies that has incorporated the macroeconomic factors that can really impact the non-performing loans. And those macroeconomic factors may include the GDP, disposable income, unemployment ratio, or the monetary conditions of the country. So there is another strain of the studies that has focused on the microeconomic factors that is particularly related to the bank-specific factors that can include the banking efficiency, their solvency ratios, their capitalization, their leverage, and there are different performance measures that has been used to look into to be considered as a part of the NPLs. So, and there are also studies that has combined the both micro and macroeconomic factors, but we haven't found any studies where they have incorporated the environmental factor as an antecedents of NPLs. So here we try to find out this evidence if there is any connection between or the link between these natural conditions with the impact on the non-performing loans in the banking industry. So in this study, we try to fill up this gap through using the drought conditions in New Zealand, where we have used the pasture growth index as a drought indicator. And then we use the bank's agricultural non-performing loans. And we looked into at the sectoral level, like at the dairy sector and sheep and beef farming sectors. Because we use the pasture-based drought indicator, that's why we use the pasture-based sector to look into their portfolios, non-performing loans portfolios at the regional level. And so how did we just constructed our sample? We just use our NPLs data. And the non-performing loans data is being obtained from the Reserve Bank of New Zealand, and the quarterly dairy and sheep and beef sector non-performing loans has been obtained from the major banks that are being involved in the loaning to these sectors. And we use the data at the regional level rather than at the country level. And then the time frame over here we considered is from March 2017 to 2020, June 2020. The time frame is really very short because of the availability of the data, because we used not only the RBNZ data, but we also used the Federated Farms Banking Survey data. That survey data provides us the information about the locations of the debtors, because we consider like it is more important to look at the debtors locations that has been impacted with the drought conditions, and then try to link it with the bank that where they have applied for the loan, or they are under the stress condition and they are not being able to pay off their loan. So we use that data from those surveys, and the surveys has been started up collecting information from 2017. So unfortunately, we have the information from 2017. Although the time period is short, but we look into the quarterly data, so it is sufficient to get some really results that we can really rely on. And then for environmental data, we just use the NEVA, and where we have obtained the pasture information about the pasture growth index. The index provides the daily based information about the growth of the grass, in considering the temperature, sunlight, and the precipitation. And then it has been measured at each grid station level, and that grid station covers the 5x5 square kilometer apart, and there are around 11,491 grid stations. And we have a very long data set on the daily basis from 1972 to 2020, but we use it to link it with the NPL's available data, like from 2017 to 2020 for this study. And then we just use those geographical locations to connect it, to link it with the dairy farmers' locations that we identified through the Stats and Z dataset, which has provided the information in their agricultural production service. They have provided the information about their locations based on the mesh block codes. So we'll link those the grid stations data with the Stats and Z geographical locations data. And then the nearest distance between the two identified the location of the dairy farmer or the sheep and beef farmer. So after having the data on the NPLs and the environmental, we just linked the both for our study. And there was like, we have 5 major banks and there are 16 regions. So we can say like we have 80 units that we have incorporated, and there are over 14 quarters that we looked up in this study. So for the drought identification approach, as I already mentioned, that we have the information about each grid station. So we have to identify some threshold how this index can really use to identify the drought. So if the index overall lies between 0 and 100, that shows the growth of the grass. The more, the higher the value means there are favorable conditions for the growth of the grass. So or the pasture, or so if the values are really reduced, that means there are dry seasons going on. So we have identified the 2 thresholds as a mild drought conditions and the severe drought conditions. For the mild drought conditions, we say, because the drought has to not only have to incorporate the severity of the index, but also the frequency, how long the occurrence has been done. So for this reason, the first threshold where we say like if the index value lies less than 30 and it remains less than 30 for consecutively 10 or more days, then we identify it as a mild drought condition. And if the index value remains below 20 and it remains below 20 for consecutively 20 or more days, we identify it as a severe drought conditions. So based on these drought conditions, we assigned each, this threshold, we assigned each grid station the value like 0 or 1. Like if it shows this threshold, we say like that grid stations shows the drought condition. And then ultimately we'll link all those grid stations with the locations of the dairy farmers and the sheep and beef farmers respectively. So, and then we, because we are looking at the region level, the data, so we sum up all the grid stations based in the region, particular region that has been located in the farmers' locations that gives us the value for the drought at the region for a particular time period. So similarly for the non-performing loans, we just have, as I said, like from RBNZ, we have the data on the quarterly basis for each sector, non-performing loans. The non-performing loans has been identified as the loan that has been not paid for 90 or more days. That we use that information, and then we just used another federated farm survey data that has provided a detailed information about the location of the farmers and their connection to the particular bank where they have loan to, and then they have to provide an answer to a question, either they have a stress condition with the bank. Like, so we use this question as a proxy to estimate like if the farmer has faced any financial stress with their banking respective bank, that has to be considered as a non-performing loan for that bank in that particular region. So we use this as a weights. We calculated it as a percentage of that, where we sum up all those farmers in that particular region and divide it with the overall total farmers in that of that bank, and then use that percentage or as a weight to multiply with the overall portfolio of the bank. So it gives us the distribution of the NPLs at the regional level. So over here, we use the list of different variables, like our main variable is non-performing loan. And as I mentioned in literature, in going through different literature, I have seen like there are specific microeconomic factors that can relate to the NPL. So we really need to control that in our model. So to control those variables, we use these bank specific measures, return on equity, and then solvency ratio, efficiency ratio, and bank size, and all the information we have obtained from the Reserve Bank. And similarly, our independent variable is the drought measure. So we use the fixed effect model in our study. So here it is at NPLs are being measured at the region level for at any time period. We have added the 2 lags because we are considering the data at the quarterly level. We added the 2 lags of the drought because we say that the NPLs takes 90 days to report into the banking balance sheets. So it will take at least 90 days to be seen in the banking, in the financial statements of the banks. So we added the 2 lags, like 1 quarter, the current time period, and T-1 mean after first quarter, and the second at the end of T-2 is the second lag for the second quarter. And then we use that XIT as a control variables, and we use the time fixed effects mu-T as well, because we say if there are the macroeconomic factors that can impact the NPL, so we really need to control those variables as well. So to control those macroeconomic factors, you apply these time fixed effects in our model too. So when we look into the descriptive statistics, we can really see like we have a good number of observations that we can look into. At the regional level, we have 1,120 NPLs values, and on average, there have been, these are 10.68 million NCD value that shows the NPLs at a region in a particular region. For our dairy farming and for sheep and beef farming, the average is really very low, because in my first paper, I have already tested the impact of droughts on the farmer's debt. And where we have seen the results, like the dairy farming is more into the debt rather than the sheep and beef farming. So we can really see the difference, like dairy farming has more NPLs reported than the sheep and beef. And the bank size shows, as I have shown, like 5 major banks has been involved. So 18.27 times on average, each bank is the representative of that whole industry. So overall, we can say those 5 banks holds 96% of, or around 95 to 96% of total asset share. So these samples are really the good representation of the overall industry of the country. Then the bank performance, it shows the 12-point return on their equity. That is really good for the bank, or the banks, like 12 times. And then the capital ratio is really very sound and good. That is really, as per the Basel requirement, is very high, like 13.80. And then the bank efficiency ratio is also being good, like 2.05. That is the ratio between their operating income and operating expenses. So when we just, these are the just comparison of the graphs that we shows the data that we have from, because we have a longer time period for our drought data. So when we just try to look into the, at the region level, which of the region can really shows the higher intensity of the droughts, we can really see that Wellington, even the Marlborough and Auckland region, these are the regions that has shown more frequent droughts over the years from 2006 to 2020. And if we look into the dairy and sheep and beef, we can say that Northland and Auckland, these are the regions that have some higher bar than compared to other regions. And when we just look into the over the years, how the different regions has reported, we can really clearly see the 2013, the highest bar, and then the 2020. So the from 2006 to 2020, we can really say like 2013 was the year when most of the areas was hit by the drought conditions. And then the next year that has is very recent, like 2020, and 2020 is included in our study period as well. So we can really say the impact can really be seen in our results. Yeah, on the averages, we took the averages of all the region level, and then we see which of the region shows the maximum average over the years. Dairy, yeah. So here I only just compare for year 2020, and the map shows for dairy, we can see really clearly see the Waikato region and Northland region shows the most of the dry period for dairy locations. So this is only considering the dairy-based locations that has shown the drought conditions. And for sheep and beef, we can only see that Northland region and some part of the Auckland has been there that has shown the dry conditions more. So when I just want to really provide some good analysis for the non-performing loans as well, but due to the confidentiality of the data, I was only approved with these results so that I can really show up. If we just look up, because this is the one based on that Federated Farm Surveys, when we distributed the NPLs at the regional level, it shows for dairy, we can see the Waikato region shows highest NPLs, and then Canterbury region, then Taranaki, Southland, Otago, the West Coast, they are some regions that has shown most of the NPLs for the banks. So it is for all banks, not for a particular bank. But while I was really want to show for each bank's results on the true data, but I was not allowed to show those results, unfortunately. And then and then if we just look into the time period, we can really see the dairy has shown a highest level of the NPLs, and it has shown big highs from 2019 and still being like increasing, and there is really a big fluctuation over there. So here are my regression results. When we just look into the mild drought conditions, we can clearly see here, I have tested this for under the 4 model conditions. Under the first model, I just simply check with the drought conditions and NPLs. And we can see after the first quarter, in the end of in the second quarter, the banks really reported the increase in their NPLs. These are dairy NPLs. And then in the second model, when we say try to control the time fixed effects, to control the macroeconomic factors, we can say again, the results are very consistent, almost the same. And then under the third model, we just added all those bank specific variables as well to control for our microeconomic factors. And we can again say the results are very consistent and significant. And under the fourth model, we just control both the micro and macroeconomic factor, and it shows the similar consistent results for that. So when we check these results for the severe drought conditions, we have seen when there is a severity of drought, the value of the coefficient really increases from 0.11 to 0.29. So it shows the severity of droughts brings more NPLs into the banking industry. So these are the results that really, under the same 4 model conditions, we have seen the very consistent and highly significant results for our study. So we have only seen significant results for dairy NPLs, and we haven't seen any significant impact of the droughts on the sheep and beef NPLs. So based on these results, we can really conclude apart from micro and macroeconomic factors, the environmental element is a key determinant of the NPLs as well. And while the banks are considering their the stress testing results, they should incorporate these climate-related issues like the drought or as a key factor in their stress testing, and should incorporate a specific loan provisioning losses towards those sectoral lending based on especially drought-prone areas. So it will be very helpful for them as well. So thank you very much.
So just whilst the next discussion is being set up, I'd just like to make a comment. It's very sad that you're not allowed to show the results by bank. We have a similar experience with our Marsden project, where clearly in New Zealand, they're afraid of disclosure and transparency. But you could have put bank A, bank C by bank D and anonymized. Sorry?
Yeah, that's what I proposed them, that I did not name any of the banks, but they said there are only 5 banks and it's easy to identify.
Well, no, because if you've got bank A, bank B, you have no descriptives on them. It's not possible. Wow. I mean, that's, it's right. Okay. That's very sad, because I mean, we need transparency on these issues, right?
So there is some data report in other ways, which is actually helpful. What you actually find, if you look at the dashboard data, you get NPLs by bank in agriculture. Yeah. But there's some quite distinct cycles for that. And there are 2 banks in particular, which had a big increase in their NPLs for agriculture about 2018, 2019. Those, interestingly, are the 2 banks which have the lowest equity ratio. So the positive coefficient on your solvency ratio is actually a bank effect rather than being anything else. It's those 2 specific banks. We also know that one of those banks bought a large poorly performing loan portfolio about a decade previously. And it took a change of management to actually identify that there was a problem with their rural loan portfolio being very high risk. So that's also tangled up in the whole process as well. But I'll talk to you afterwards.
Okay, good to have David in the audience. Okay, June, are you online?
Could you see the slide now? Yeah, thanks a lot. It is my pleasure to discuss the paper because last year at the symposium, I also had the chance to discuss the Shabana paper. And I remember that the paper is about the impact.
Hi, June. Could you please maximize your slides, please?
Yeah, sure.
Thank you.
Last year, I remember that I also had the chance to discuss Shabana paper on about the impact of droughts on the loan growth. And now this year, the paper is about the impact of droughts on the non-performing loan, a very interesting and important topic. So to save the time, I will skip to summarize the summary part of the research and go directly to the strength and some my suggestion to further develop Shabana's research. So the strength of the paper is that Shabana and her co-author used a different source of data to address the research question, and the research also contribute to the literature stream on the climate change and disaster on the agriculture sector and from a financial perspective. And this paper directly provided evidence on the impact of droughts on the non-performing loans of banks at the regional level. And the paper also provides important and relevant implications to both the New Zealand's agriculture and banking sector. I have some suggestions and maybe some questions to provide some suggestions so that Shabana could further develop her paper. With regard to the model, at the moment, I see that there is no lack for the bank's specific control variables. Maybe this could have some reverse causality to the non-performing loan. So maybe the author could try to have the one quarter lag of the bank specific control variable in the model in the robust check. And then I think maybe we should control also for the regional fixed effects, because at the moment the key variable of interest is the drought measured at the regional level, and also on the left hand side, our dependent variable, the non-performing loan, is also measured at the regional level. So maybe some unobservable regional factor could affect both of those variables. So I think it's reasonable to include the region fixed effect in the model. And one more point, have you tried to include the deeper lags of droughts in the model? At the moment there is a 2 quarter, but then maybe you could try 3 or 4 lags of the droughts variable or droughts index in the model. I give this suggestion because I see that at the moment you found no insignificant impact of the droughts index on non-performing loans of the beef and sheep industry. So maybe it could took a longer time for the drought to show its impact on the non-performing loan of this industry. So maybe try the deeper lags, maybe provide an alternative avenue, and then it also remains a puzzle, because in the first paper as well in this second paper, you find a quite different findings for the dairy farms and the beef and sheep farms, and I just wonder whether you have tried to run the model for both farms and beef and sheep industry in the same model, and then using industry dummy rather than split the sample into those two sample of the two industries separately, like in the current version of the paper. Yeah, and then the last comment is that I find that the section 3.1 is quite lengthy, and so I think it's much better to make it more concise and clearer, so that the readers can get a better understanding of how you construct the non-performing loans for each bank in each region. Yeah. So that is all my comments. Thanks, Sabana. Yeah.
Thank you, June. Shabana, would you like to reply to? Yeah, use that one. Okay.
Yeah, thank you so much for the comments. Yeah, I do agree. Like, I will try to add the lags at the bank-specific control variables as well. And for the deeper lags in the model, what I will say, because the time frame for my study is really very short. Like, I already have only 14 quarters, and if we will go further, it may reduce my more values, and it will not be that much helpful to see the results. So I think if I would be able to have more data on this or longer time series, then I will try to look into the deeper lags as well. And for the sheep and beef and dairy, it is very obvious, like the results are very different, because I already suggested in my paper, like there is a further research required to look into why the two sectors are being different, because we assume like there might be some operational differences between the two industries. That's why the dairy is being, like, if we just randomly say, like, the dairy, the cows or the animals are like a fixed assets, or sort of a fixed assets for the dairy, but for the sheep and beef, they are an operating cycle, like they remains the animals. If there are drought, they may be the animals goes into the slaughtering, and that really reduces their cost, or they meet their financial needs. So that's why we have seen that difference between the two sector. Otherwise, the drought is being hitting the two sector equally, almost equally, because we have seen in the results, like it's almost the same regions where the dairy is being hit by the drought, the same sheep and beef is being hit by the region as well. So I try to find out some papers as well where they have some operational differences between the two sector has been clarified, or but I couldn't really find the clear differences. But that's why I do suggest we may need some further research over that. And to run it in the subsample, yeah, that's a good idea. I may try to use it as a dummy as well, but I doubt, like, it will not show any differences in the results. That's my idea, but I definitely need to check that. And for the writing, yeah, as I said, like NPLs for each bank, I am, unfortunately, I'm not allowed to report NPLs for each bank in each region. But for the construction in writing, I try to define it, and then I try to model it mathematically in the model section as well. So if the description is not clear, then at least some mathematical equation makes it more clear. Yeah, thank you.